This is a demonstration for in-class exercise 1. So I believe for question 1, question 2, question 3, and question 4, they are pretty straightforward. If you already know time value of money, question 1 is just for calculating present value of these future cash flows. And I believe you can solve that. So for question 2, we're still using the present value idea here, but we're actually using NPV function in Excel to calculate the present value. And remember that there's a differences between the real NPV and Excel's NPV function. So Excel's NPV function does not include the initial cost. So you actually need to subtract the initial cost after you have used the NPV function. And for question 3, basically we want to compare the PV function with the NPV function. So although they will give you the same result here and here, but the way of using the function are different. Same here for question 4, which is asking you to calculate the internal rate of return. So now I'm gonna give you a demo for question 5. So question 5 is also a simple illustration of how to calculate the payment for a loan. So the loan we have here has a principal equals to 10,000 and the interest rate equals to 7%. So we have 6 years to pay back the principal. So now we want to calculate the annual payment using the payment function. So we're going to start with equals PMT, the payment. Now here, the first term should be the rate. So the rate is the interest rate. Second should be the number of periods. So that will be 6 years. And finally, we'll input the present value. Now I'll just go ahead and select present value. So you're probably going to see a negative result here. So to change that negative, we need to instead put a minus sign here for the present value. Okay, now that we get the correct number for payment. So that means we need to pay this payment for each of those following years. So I'm gonna enter the payment at the end of the year first to equals to cell B5. I select enter. Now that if I drag it now, so it's not gonna equals to $2,097 every year because it actually will go down to the cell below. So I just want to fix the cell here by adding the $sign. Okay, so I enter, and now it will be fixed. So every time it will reference back to cell B5. Now at the beginning of the year, the principal should be just the $10,000. And the interest here should be cell B3. Again, we want to fix B3 because the interest rate is the same for all those following years times the principal. Enter. Return of principal equals D9 minus E9. Enter. And then I'll just first delete these 2 arrows and then double click and also clear. I don't want this. Okay, So now we finished this part and I just want to wrap it up. So what we are doing here is we have a principal at the beginning of the year, and then the fixed payment we calculated that we'll pay at the end of the year. And this is the principal. So the return of principal is actually the payment we pay at the end of year, subtracting the interest rate, because the principal will require this interest payment. So therefore, actually, our principal at the beginning of the year of year 2 is $10,000, and then subtracting this 1,397. So finally, to clear this position, you get a 0 at the end of the 7th year, at the beginning of the 7th year. So next, so for question 6, it's actually using the similar method, but we'll change a function. That is, we're using XIRR. The value here is these numbers. The date is here. Enter. So the difference is we're not entering any number of periods, but we are actually using the actual day. Okay, so that's the difference of using XIRR instead of IRR. Similar here for XNPV. So the rate, cash flows, and date. So then here, starting from question 8, we're gonna use data table. So we have a series of cash flows, and here is our calculation for IRR. And now we wanna calculate NPV and to see the sensitivity of NPV to the changes of discount rate. So to calculate NPV, we actually can use the NPV function. So this is our header, and we want Excel to use the same formula to produce all of those following numbers. So this table will give us the NPV given a certain number for discount rate. For example, here, when the discount rate is 10%, then the NPV will be $200. So when the discount rate goes to 16%, the NPV will be negative. So the higher of the discount rate, the lower of the NPV. So now that you can answer the question here. Here we are using a similar method. So we're having a discount rate equals to 6%, and the NPV is the NPV of this series of cash flows. So this cash flow has one difference than the previous cash flows. So we'll have a negative cash flow at the end of the 5th year. That means these are unconventional cash flows, which means that we probably will have to internal rate of return. So let's first calculate the data table to see the sensitivity analysis of NPV conditional on changes in the discount rate. So this will equal to the NPV directly here. And then I'll start producing the data table. Column input is the 6%. So this is the discount rate that we use to calculate this NPV here. And this is our data table header. Okay, so as you can see from this graph, this is simply a graph of these are NPV, and this is the x-axis is the discount rate we use for calculating each of these NPV data point. And you're going to see that this curve crossed the 0 twice, right? So there will be 2 solutions for NPV equals to 0. Now that means there will be 2 IRRs. So how to calculate 2 IRR? We're actually going to still use IRR function. So the value is here, be 6 to be 11. And then remember the way of calculating IRR is to use try and error method. So we first want Excel to have a guess range. So the guess range for the first IRR should be around here, as we already have a graph showing us some hint of where should be the range of the first IRR. So I'll give Excel this value of perhaps 0 to find the closest IRR, and that is 8%. That is likely here. And the second IRR, I'll let Excel know somewhere close to this point. So the guess range maybe is 0.3. Okay, so then the second IRR here is somewhere here, 26.65%. So finally, for question 10, we're trying to here solve for the estimate of this regression line. And if you click on this graph here, this is the scatter plot of X and Y. So it actually shows you if the fitted line, if you add the fitted line here, this is the linear regression model. And this should be our slope, and this should be our intercept. And as you can see here, the slope is 0.6381, so 0.6381, and then the intercept is 0.0038. And the R square here is actually 13%. So now, here I want you to use regression functions to calculate in intercept and slope. So basically, it's pretty straightforward. You just don't want to mix Y with X. So make sure you know what is Y and what is X here. So the Y here should be the return of when, okay? So actually it's this one, and the X should be the return of MCD. So same here for the slope. Okay, and now I want you to write down the regression model. What is our model in terms of, so our regression model. So what is A and what is B?